Hello and welcome to Digital Futures technical tutorial sessions. Today's session is a continuation to our previous session by Mohammed Behjoo on developing custom components in Grasshopper using Python. Before we begin today's session, I would like to remind everyone that we also have started Digital Futures Arabic and Digital Futures Farsi sessions. We had a very beautiful and a very successful session yesterday on Digital Futures Farsi. Mohammed here is also the co-director and the founder for Digital Futures Farsi team. Without further ado, I'll just like to introduce Mohammed and give a little bit of background to his work. Mohammed holds a Master's of Science in Computational Design from University of Tehran. His main research topic is using AI in architectural design process, automating the procedure and generating novel forms. Mohammed has a unique academic background and experience in architectural design, computational design, and AI. He ran workshops on AI and computational design in both English and Farsi. He is Digital Futures India Regional Manager, along with his position as Director at Digital Futures Farsi. I hope you all enjoy the session today. Mohammed, the stage is yours.
Thank you, Bobline. Hello, everyone. We had another session. Our previous session was about going through the basics of Python and in Grasshopper to the more advanced topics, to the intermediate topics. And today is a continuation on that session. So let me just go without any other hesitation, go there, and let me share my screen. Okay. So I'm not going through the basics once more again. So I just continue from where we left. So can you see my screen? Let me share it again. I'm not sure if it was
Yes,
shared.
we were able to see. Yeah.
Okay. So you know, we had we went through some basics like how to create surfaces or how to create how to panelize meshes or surfaces, how to do this very customized through a customized procedure. But now let's start with some surfaces like GH here, and we have more time now. So we can do it more in depth. So let me, oh, sorry. Oh, I hit that button. Okay. Okay. So we want to create a surface, a smooth surface like a wave that is created from points. So I want to start importing my libraries. I import Rhinoscriptsyntax as RS. So as we knew, when we use this keyword as keyword, we don't have to write this long name Rhinoscriptsyntax or any other long names of the libraries and packages again. So we just have to write this in order to call the library. So after that, I import math. This library is for mathematical operations, and I'm going to create a list. So we want to have some points, you know. I'm going to create a list and call it A because we have A in the output. And I'm going to use a for loop for I in range. Let me, for example, for range X, I want to specify the X here. We want an integer, a whole number. So like 12, for example. I give it to x and set the type into integer, because we must tell Grasshopper what data type it is. So it is an integer. And I just click this, and now let's go and do some thing like this. And for j in range y, so I want a 2D, a two-dimensional grid, like the x is the for the first dimension, and for the second dimension we have y as a controller, so we can control this. For example, let me say 15, maybe I can change it anytime. So as we said, we are here to do rs that I want to append or add something to this list. So I want to create some points, a collection of the points. So a.append is going to add these these points to that list. And let's say we are here. Let me find my glasses. Sorry, where is it? Okay. I want to append these things and use Rhinoscriptsyntax. I just write rs because it will call this package, this library, Rhinoscriptsyntax, rs.addPoint. Add point, it will suggest, let me add point. I want to have some point, and I want to use I as its x coordination, its coordinate, and j as its y coordinate, and for its z coordinate, for the third dimension of every point, I'm going to use mass library. So mass.sinus and mass.sinus I. Let me just say now I. So, and I'm going to show you what is the output. Okay, line 6 got float, range, integer. Okay, I have not specified the data type here. Okay, so this is it, and let me just do this. Okay, and let me just move the zoom controllers. Okay, so it's because the z coordinates of the point are we used the sinus function from the mass library for just having a sinus wave, and I can change the points, the number of the points, by changing this and this. And now let's go and change it a little bit. And for example, let's add a height factor, and let's call it height. And I want this to be as a float because I want decimal numbers for the height, 2.5, 3.2, such numbers like this. For example, 2.3. Okay, 2.3 unit for the height, and let's involve that height here inside the sinus function. So as you can see, we are controlling the height of it. You see, it is like this. The sinus is the multitude of it are changing based on this. So I want to have something like that, and let's change it a little bit, a little more, and mass dot sign. Okay, and j dot multiplied by height value, and let's see if it is okay. And we want another parenthesis. Okay, so it is like this, it's a two-dimensional wave. Let me just do this so we can see. We can change the amplitude of the wave, as you can see, every time it is going to be changed based on the value we specified. So I'm going to have this value. So it will create a wave like that, and the points are going to be like that. And let's have another factor. We call it distance. Distance. This distance. Okay. Set it as a floating point number. Okay. And let's have, for example, this and this maybe. And let me zoom out so you can see the script. And here we are going to okay, we are going to have this as another factor here, and we are going to involve this in the operations, in the mass operations. So let me show you how we can, okay, how we can change. You see, we can change the amplitude of the waves, so by this factor. So let's move on, and now let me maybe change it a little bit, and let me make it bigger. So okay, we can create a definition. A definition is like a function, or if you are familiar with C# language, C# programming language, they call it methods, functions, such things. In Python, we call them Python. We call them functions, and we specify them by writing such thing, you know, by typing def. Def is the abbreviation. Def is the abbreviation for definition. So it will specify. It specifies that we are creating a function. So after def keyword, we want a name for our function. So for example, let's say points. The name of our function is points, and we can give it as many as we want, as many arguments as we want. For example, now in this case, we have two arguments. We have two inputs, you know, x and y. In here, as you see, in here we have x and y, and after that we put a colon, and we indent the line by 4 spaces or a tab. If you press tab, it will do the job. So, and inside this function, we had this piece of code, as you see. And let me just okay, I just copy this and go here and paste this into here. Okay, we have a, I don't want it to be inside that function, because every time if this initialized empty list was inside our function, every time we call the function, it will empty that list. So we don't want to be like that, you know. We want it empty every time we call the whole piece of the code, the whole piece of the script. So I place it here outside the definition, outside the function, and every you know, okay, I have some, I should indent them one more time, and now it is a piece of that definition. So every definition or function in Python can return something. It is you can return, or you can return something, or you can return anything. It is your choice, and it is and you can choose it whenever you want. But now we want to return a, and a is the points here, you know. I can let me, for example, point list, and let me call it point list, so it can be descriptive, self-descriptive. Okay, and let me check if, okay, and we want to return the point list, the values and the points, we want that. So let me do this and let me hide it, so we don't want that, and this. Okay, type hint here, I define the type hint and type it here, and so we have it. Okay, let me, and you know, this is just the function. We should call the function, we should use the function, as you can see. For example, points x, y. So now we will see global name math is not okay. I did not import math library, so that's it. And height. Okay, we have height and two other things, distance and height. Okay, let me just have them. Okay, set it as float and distance. That's another factor. Okay, so we can have line 9 point list that append unsupported operand type for integer and non-type. Let me just check it, and after that, okay, I think we should specify these things. After that, yeah, we are good to go. So, and you can see, okay, we want to have these, as you can see. Let me do it one more time. Okay. And let me just figure out what's wrong with this. Okay, the amplitude. Okay, I rename it to amplitude. Let me just have it as amplitude. Okay, and now we have it. As you can see, when we define a function or a definition here, we can use it wherever we want. For example, we can use it here and 50 lines over there, and we can use it with another piece of, for example, Z and P and such things. We can use it as many times as we want. So that's for reusability, you know, and the functions make it easier to reuse your code whenever you want. So let me hide it, and let's just get back to there. And let me just have a time parameter. Let's just involve the time parameter in it. So we knew that we did something like this if P is in globals, so it will check all the variables and it will search for the P, the character or the string P. So after that, if we tell it that if we have P in our variables, just do this, P plus, let me just make it simpler, plus update the value of P by 0.1. So, and we have an else here, else a statement that says that if we don't have P, just initialize the value of P by 0. So that's like it. That's it. And we want to involve the P or the time parameter here inside our script. So what we have to do here is something like this, for example. Let me, for example, okay, and let me, okay, where is it? And let's test it. If P is in globals, P is in, okay, that's not necessary. Yeah. So I'm going to show you this, as you can see, and let's bring a trigger component. And if you use Rhino below version 0, you have to bring such things timer, not time. But after Rhino 7, after the announcement of Rhino 7, they changed the name of timer component into trigger. So let's set it as this. As you can see, this is it, you know. Let me just make it a little smaller. Okay, such things. And we can create a mesh out of our points. So you can see it like that. You see, we are having a sinus wave, multiple sinus wave. Okay, let's just disable it. So let me disable this and create, okay, delete it. Okay, so you know, we have a component like middle, curve middle. For example, we have a curve here and we want to find the middle point of that curve. And as you can see, the middle point of the curve is here. This is the curve, and this is the middle point of that curve. We can write it in Python, and we can make it a little bit complicated. So we can develop it, and we can make it a little bit complicated into some a smoothing component, some custom smoothing component. As we can see here, for example, we have midpoint as our variable name, and we have first point, for example, and second point. Okay, and you know, we are going to do this and this. We are going to make an average of the points of our first point and second point. And let's specify our first and second point. For example, first point, and make it make the typing as 0.3D. Set it as 0.3D. Okay, here, and second point. Okay, and we want let's see. Okay, and we want to return the value. In this case, we say a equals a is this, or we can just say midpoint as our, if we don't want to write this line. So, and let's specify 2 points. Okay, and let me just, for example, this and this, and okay, let's set the first point, set the second point, and you can see here our middle point. Let me hide these 2 points. So this is our midpoint. Okay, so this is something very simple, and let's change it into something more complicated or something more complex. As you can see, when we divide something by 2, we can just multiply it by 0.5. They are the same. And when you are coding, it's better to use multiplication and additions instead of using subtraction and divisions, because the computers uh, are some like some devices that they are adding lots of zeros and ones. So it's their nature to add something, and we know that multiplication is another form of addition. So it will make your code faster, but not here, because it is a simple script. If you have lots of lines of code, you should pay attention to these simple tricks, and they are very important. So let's just have a parameter. Okay, float, and for example 0.3. Have a parameter like this first point, and change the first point into such things: 1 minus parameter, and this second point plus parameter. Okay, we are going to evaluate the curve, you know. Let's run it and let's see. 0.8. Okay. Okay, this is like it, you know. We can have this, and let me just show you. As you can see, this is our first point, our second point, and the point that we want on the curve like this. We can change it. Okay. And you can see, let's move on to something more complicated. For example, let's have lots of points, not just 2 points. Let me just set lots of points on the screen. Yes. Okay. Yeah, I can share the files of GitHub files with them. Let me just send the link to you. Okay. GitHub. So you can have the files. Okay.
Yeah, I just
okay.
posted the link. Yeah. Okay.
Thank you, Bowling. Okay, so let me get back to Rhino. So I was telling you that what was I telling you? Okay, let's just do this on a set of multiple points like this. For example, we have 3, 4, 5, 7 points, and let's say here, let me create a duplicate and delete this and delete this one. And for example, let's say, for example, points. Let's call them points. And let's, you know, here, this is something you should be careful. When we have just one item, or when we just want to process every item of a list or such things one by one, we set these the access to item access. But when we want to process a list of data or a list of geometry, we set it to list access. And as you can see, we have 3 access. You are of course you are familiar with Grasshopper and how it processes the data. We have a single line and multiple lines, such things. It is the same. It is similar as that. So that's why I have multiple points here, and I set this as list access because I want them, all of them, to be processed once, at once. So I'm going to set multiple points, so it is okay. Let me, yeah, it is okay. So, and let's, okay. I want to print len. Len is a built-in function of Python. It will print out, it will give you, or it will return the total numbers of items in a list. Okay, and we have our list as points as we specified. So let's see. Okay, we have 7 points. As you can see, we have 7 points. So let me comment it out. Okay, so let's go to another, and we have A as our empty list, and for I in range len points, this part of the code tells the range function, you know, I can just let me just show you what it will return, because you know that range function only accepts data type of integers. So it accepts only integers. As you can see, we can have, let me check the, sure, Andros. And let me check here, print len points. And as you can see, let me press F5, you can see it returns 7. And we can just say what is the data type of that thing, that this part of the code inside type that it will return. So it will tell you that it is an integer. So a range function only accepts integer. So that's why I used len points, len parentheses of points. So the value of this part, the whole of it, is an integer, and range accepts integer. So let's get back to what we were talking about. Okay, and for this, and let's just go and append points. And as I told you before, we can access every item of a list by doing indexing. And this is the syntax for indexing. As you see, we specify the index inside 2 square brackets. So I want to access to every item that the for loop is iterating over the points inside that list. And for example, 0.75, and this, let's say this is another, okay, plus points, where is it? I plus 1, and this is multiplied by 25. You know, we want the first quarter of the line of a line and the third quarter of that line, and we want that point on that place. So this is it, and another parenthesis here. Okay, A is not defined. Okay, here we define it now. Index of out of range. Oh, okay. You see here we have a runtime error, index out of range exception. When you see, or when it throws some error, you should read it carefully and see what it says, what it told you. And you know, it says that index is out of the range. So we know that the index that we are providing for the range function here, it is out of the range of it. So I know why that happens, because when we start from 0.0 and when we start from 0.0, we will get 0.0 and 0.1. 0 plus 1 is equal to 1. And it goes on. When we get 0.1, we get 0.2 at once. And when it reaches 0.7, because we had 7 points, when it reaches the point number 7, it gets point number 8 too, but we don't have point number 8. That's why this error happened. So we can just do this and it would be fine, you know, because we don't have the point number 8, and when we subtract 1 from it, it will be okay. And let me change it to A. Okay. And okay, and let's go and change it a little bit. So okay, and you know, we have for example, okay, let's call it midpoint YA. We should use descriptive names. It's better to have descriptive names when you are coding. Okay, points. I should add an S here. Okay, midpoints. And we have midpoints, and we add the first quarter and the third quarter of it, and we want to have such things for it. And here, let me change it. Okay, and let me change it a little bit so we can see the differences. Okay, let me, yeah, we want the first line. It will add the third quarter of it and the first quarter of it, and the second line is going to be like the inverse of it. So let me just do this, and let's say parameter. Did we have parameter here? No. Okay. So, and you know, okay, we have points here, and we don't need parameter here. So what is it? Midpoint. Okay, midpoint. Oh. Okay, points and point 3D and distances. Okay, as you can see, you see that our points are these 7 points that are green now, and our midpoints are those desired points on the first quarter and third quarter, first quarter, third quarter. As you can see, it is like this. And let me show you with a polyline, and let's connect them together. As you can see, it will break them, and we are going to see as a subdivision of the line, or the line between those points. And you can see when we change it, let me go to the top view. As you can see, it is going to change the value. So, and we have these here, and let's just say we can have the discontinuity of those, and we can just do this. Okay, and do this. As you can see, it is going to be more smooth, and it will just be like this. Okay. That's like how they make animations or smooth curves in those softwares like 3ds Max or such things. As you can see, the line is getting smoother every time. So you see that we have lots of repetitive tasks here. And this is our initial, no, this is our initial part of the script. So we can change it into a for loop. As you can see, let me just do this. Okay. And now we have just our initial curve. And let me just, yeah. Okay. And let me change it a little bit. Okay. So we have point, for example, PT, and we have B, another thing here. Okay. B. We have B here, and we have midpoint. And let's say, let me just change it. Let me go to the first of it. Okay. How we can perform iteration in same script for such codes? Yeah, I'm going to do this now. Thank you for asking. Okay. Let's just say for I in range, of course, number of, for example, number of division. Yeah. And let me have another thing for that, so we can have the for loop number of division and set it as integer in here, number of division. And let's have another for loop for I, for example, or j, I in range, no, range, yeah, range len points -1, because we know why we put a -1 now. And pt dot append, now we don't want midpoint, as you say, they are not midpoint, so I called it pt or point. Pt append dot points I, where is I? Okay, I 0.71 75 it is not typing. Okay, 75, and let's say, and yeah, plus points I plus 1 and multiplied by 0.25. Okay, and we can copy this line into this and change it to this. Okay, and now we can have, for example, points as pt. Now we have another variable. As you can see, we have a pt and initialize an empty list that we initialize it empty, and we are going to iterate every time through that number of divisions, that for loop every time, and it will create those points that you saw, that the subdivisions was formed based on them. And we don't want to lose them, because if we don't have points here, we don't have this variable here, every time we run the script, the list is going to be emptied. So we don't want this. We want to save them. We want to have them. And after that, I tell it, just for sanity check, empty the list. It is like that, the list is empty. So, and a equals to points. we have, let's say, have here A. Okay, we have A and we have B, and now we don't even want to use this. Let me show you, because we don't want to use this, because we can just use Rhinoscriptsyntax to have add polyline, and we can use this A. As you can see, the add polyline function accepts points, and the points are going to be a list of 3D points. So that's why we create a list, here. And let's run it and see the results. Okay, integer range argument, line 6 for I. Okay, we did not specify it. Let's give it a number. Okay, that's it. As you see, those repetitive tasks came into such thing. As you can see, we can have this and we can just smooth it as we want. So, for example, we can change it and they are going to be updated. You see? So, let me hide it and let's move on. Let me hide it. Okay. And let me hide the points. Maybe we want them, or let's just move them. Okay, let me move them. So, and after that I want to hide them. Okay, and my battery of my mouse is dying, that's why it is jittering. Okay, and we have panelization, and I taught you that how to panelize and how to do the panelization, a custom panelization, but I'm not going to through that again. But let's just let's work with another library. It is called GH Python lib, GH Python lib, or GH Python library. Let me import GH Python library that components, yeah, as ghcomp. Okay, and we have Rhinoscriptsyntax here. What is this library? This library is the components we have in Grasshopper. For example, we want to, let's see here, sets, for example. We want to use partition list, but we don't want to, we don't have partition list or something in Rhinoscriptsyntax, and what we have it in Grasshopper itself. So we can just import its component, the built-in components of Grasshopper, as GH Python lib .components. So we want to extract, what we are going to see is how to extract the surfaces and the vertices, the edges of a BREP, So we want to have faces, we want to have edges and vertices. Faces, edges, vertices, yeah. And we have ghcomp, yeah, ghcomp dot, for example, the construct here. The construct is something, the construct BREP, as you see. Let me just do it so it can, the construct BREP here. For example, we want to have a BREP like this. For example, let's go to Rhino. Okay, let's go to Rhino and let's have a cube like this, as you can see. let me just close it here. And we want to have this brep and set one brep. So it is set, and we want to deconstruct the brep. Deconstruct the brep. Deconstruct brep. Okay, here. We want to have the faces, edges, and vertices. As you can see, it will return every face, every edge, and every vertices of a brep. But we don't want to have this out of our script. We want it inside our script because we cannot use it outside our script, and it is not good to use it outside that. So we can just import it through this library. And you can see we have brep, for example, brep. And let me tell it that what is a brep. Brep here, the name is brep, and type hint is brep. And for example, okay, so we want to return this, faces and index, for example. Which face? We want face, we want just a single face. For example, a single face of those 6 faces of this cube. So we can just, because we know that faces, as you can see, let me show you, print type faces, and let's just hit F5. As you can see, it is a list. The faces are a list. So we can use indexing faces, and we want to have index. So we want another factor as index. So I call it index. And index should be an integer. It must be an integer. So for example, from 0 to 5, because it has just 6 faces. And let's see, for example, here, face, okay. As you can see, let me just do it, and let's hide this so you can just see the face here. As you can see, we have just one only face. We are going to create a component that it deconstruct a brep, and it use such things that list item. So we don't have to import list item, deconstruct brep, and and those similar components of Grasshopper. We have them inside our script, so it is better, and we can access every bit of the data, but not that way. It is not flexible that way, but this way, when you are using Python, it is more flexible. So, and let's say, for example, curve of face. Curve of face, for example, gh comp dot gh comp dot for example, brep or wireframe. So okay, gh comp dot brep wireframe is going to return the curve, the peripheral curves of a face. So we have this, and let's say we have curve of face. Let's have it as an output. Okay, and you see, this is it. And let's just curve of face. Okay, I'm going to use that curve that curves of face curve of face one in another place, but let's just go and use that in another place. So for example, we have curve of face, and which face here, curve of face here, we want this curve of face to be because the curve of face we can see, let me just, we can every time we want to see the data type or the type of that thing that we are working on, we want to see what it is. So curve of face here, we can print this, and it says that it is a list, as you can see. So and let's go, and so we were here. Curve of face, we want curve of face to be something like curve, because it is a list, we can do list indexing, curve of face, and the index, for example, index one more index, not that index that we have, curve index curve, index curve. Okay, set it as integer, give it a number, and we are good to go. Okay, let's see what's happening here. Okay, let me just check the thing. Okay, and let me, okay, so this is the curve, and this is the face, and after that, let me, what, line 9 curve, yeah, that is fixed. And we can have the points of a face, so we want the points of a face. For example, points of face can be like this, and let me tell you what this part is, the comma and an underscore. I will tell you in a couple of seconds that ghcomp discontinuity, of course, yeah, and face or curves. That's why I use curves here. I created another variable as curves here, and tell it to do this. As you can see, this continuity, when it returns points and parameters, but here we just need points, not parameters. So this piece of syntax will tell the Python or the interpreter that we don't want the second part of the return. So we just want the points of this of the face. So, and this is it, and this is nothing. So you can just go on. It won't make any problem for you. These warnings, they are just warnings. So we want to have points of face, for example, and let's all points of curve is equal to that. And as you can see, I'm going to use the same syntax here, ghcomp here, and dot. So ghcomp here, discontinuity, and now curves. We want points of the curves. And oh, sorry, there is something wrong here. Curve of face, because we want the points of face, and now we want the points of every curve. So, and after that, we want center, for example, of face or surface. Let's call it surface. Yeah, and we don't want these things, and this is it. rs dot surface area centroid. It will return, as you can see, it will where is it? It will return, let me, a list of points, tuples, numbers, those things, or area centroid information. So I'm going to specify as a face, as we have face here. We choose the face, and every bit of information of it will be returned. So let me get back to there. All points curve here, and center of surface here. Okay, and let's see what are these things. Okay, this is it. As you can see, we have a face, the curve, the face, the points of it, the points of its corner, and the center of it. All of them in a component. So we don't have to use lots of Grasshopper components to just have these, and it is more flexible and better to use it like that. Okay, let me do it. Okay, so let's just disable it, and let's go to another example. Let's have a polyline with an arbitrary formula. Let's import math and import random. We want to use random. Okay, random here. And let's say, for example, x coordinate and y coordinate are going to be some lists, some empty lists. So we can use them here for I in range x. What is x? We can specify x here. For example, x is here, and integer, it is an integer 12, for example. Okay, and 5, 3, 4. Okay, such things. And okay, and I'm going to just x coordinate dot append random. I'm going to call random library, and after that random method. So don't be confused. This is random library, and this is random method inside random library. We call that method. So we are going to have a random number. Random, this random, as you can see, it will return a random number between 0 and 1. So a random floating point number. And we want to, for example, we want to have a random factor, maybe, yeah, random factor. Random factor, let's have it as integer, and have it as, for example, 3. Or no, let's have it as a floating point number. And this is it, for example, here. And let me just between 0 and 1. Okay, like this. And okay, so we have random. Let me make it a little bigger so I can random factor. Random factor here, and plus factor, for example, factor, another factor. So we want some some factors to be involved, for example, factor A, and we want factor B. We want 3 factors to control it more precisely. You can have as many factors as you want. And factor B and float. Okay, let's do this. For example, here. Okay, factor A plus, it is an arbitrary kind of polyline. You can find the formula for polyline on the internet, and you can change it whatever you want. I'm just playing with the formula, you know. It is not nothing very well defined. Okay, math dot cosine of 0.5 equal I. Okay, I'm going to copy this and place it here, and let's just have it as this. And random factor, yeah, random factor B, and for example, let's have 3, let's have 2 I. Okay, I forgot to place this, and let's call sinus function here, and let's have 3 and 2. Okay, we are good to go now. And let me see what's wrong with this. Unexpected. Okay, this is it. No. Yes. Okay. Yeah, this is it. Okay, so everything is fine now. Okay, so, and we can change it a little bit. Let's go on and change it a little bit to, for example, let's have if P in globals, let's check the variable names, and if P was there, let's have it like this, P plus 0.1. This is the equivalent as this, P plus P equals to P plus 0.5. So it is a longer version of this, so we can use this, plus equals 0.5. And else here, else, let's say our P equals 0. Okay. And let's move on, and we have this, for example. Now we can have another list as points, and we can print the list of points, print the length of the point list. Okay, and for example, now let's make it a little bigger, a little smaller, like these and these and this. We have random factor, for example. Let's make it bigger. Okay, and for example this, and let's make them bigger too. For example this, and the maximum value here is going to be set as 6, and we can change it whether we want or not. Okay, and we can have it, and for example, let's see. Okay, and we want to have an if statement. If length of points are going to be bigger than limit, so we want to have a limit, so a limiting factor. and the limit factor is going to be an integer, for example, 15, 50. Okay, not 15, maybe 60, and whatever you want. It is not, it doesn't matter. And let's say points dot append. We created points, yeah. Points dot append rs dot add point here, and rs dot add point x coordinate and y coordinate here, and for the z coordinate, let's say 0. Okay. So we say here, if the total number of the points created are going to be smaller than the limit, in case here, for example, 65 or whatever you want, add those points to this list, to this empty list of points. So, but else, we have an else statement here, or let's say no, if, another if length points is bigger or equal to limit. If it reaches the limit, what it says is points.pop. What pop function or method does here, it will just delete the last item of the list. So you know we are adding points. We are adding points, and when it reaches a limit, it will just delete the last item. So we know that the total number of the points are going to be exactly 65 every time. And let's say we have polyline, for example, polyline. Okay, we want polyline here. Polyline. Okay, polyline rs.add polyline, as we saw earlier. rs.add polyline. Okay, and points as the input. Points list as the input. Let's see what's the got float expected.
I think
float,
it's polyline spellings in the Grasshopper component.
Yeah, it is here. You know, let me just debug it. Okay. And let me check everything. So yeah, I think it is okay now. Let's just do it one more time. Yeah, it is okay. So yeah, and we want a trigger because we want to involve the time parameter. Okay, here interval here, and let me check the check. Let's check a spelling of polyline in GH component. Okay, so we have we want to have points as another points. Okay, these are the points. As you can see, the points are not going to be bigger than a number, and we want to have, for example, we have what did you have here? Okay, we have x, and as you can see, we want to have lots of points. Let me just make it white, and you can see here they are not going to be bigger than this. So we have a limit. We can just do this and change the limit of it, but it is not going to be bigger than this. So we have lots of points here, and we are going to have, for example, let me just compile them together, maybe combine them together. Okay, I think it is going to be fun. Was it this? Yeah. And we have points here, and we can give it to that, and we see that, let me just make it like this. Okay, as you can see, the random, we have some random number in here. So the x coordinate and the y coordinate are random, and the points on the surface on our axis are going to be placed randomly. But we have lots of points, and you can see, for example, we have something like this, but the total number of the points are not going to be bigger than this. And you see, we can use them, both of them, and let me just disable them because I don't want to use my computational power sources here. Okay, let's go to show you some how to create fractals through recursion. Recursion is something when we call a function inside that function itself. So Python, okay, and we want to work with import Rhino dot geometry as RG, okay, and import mass library, and I don't know, maybe, okay, so let's go on and let's create a fractal function, def fractal, and we are going to have something like this. We want to create a fractal between 2 points, pt1 and pt2. Okay, set them as point 3D and set this as point 3D, and let's have point here and point here and give it to that, or let's have it like that. I don't want to set point on here. It is more flexible to set points in Rhino and give it to Grasshopper. Okay, so let me make it bigger. Let me change the move zoom controller. Okay. Point 1 and point 2 as our inputs, and we want to specify an angle between them. So we want to know, we want to change the angle and want to control the angle. Okay, control no, angle. And the angle is going to be a floating point number. For example, 60, I don't know. We can change it however we want. Okay, we are going to create a curve first of all. We are going to create a curve, of course, and let's call it, for example, let's call it line. And after that, we are going to rs add line. It is not rs add line. It is now, okay. Rs add line, point 1 and point 2. So it will draw a line between point 1 and point 2, and it will connect them. And we want to have another point, points rs dot add rs dot divide. Let me rs dot divide rs dot divide curve. Okay, divide. Why I'm not divide? Okay, divide. Yeah, divide a curve, and that curve is going to be line. And as you can see, it will the input is going to be such thing as a curve ID and the segments and such things. So we don't want to specify these things and give it these things because they have value, they have default values, but the segments are going to be, for example, 4. So it will just break it into 4 parts, that line into 4 parts, because let me annotate it here, draw it. When we want to have the snow, let me, okay. Okay. When we want to have a snowflake, it is like this. I cannot, okay. Let's draw it one more time. Koch snowflake is like this. And we have a line and a straight line like this. So we want to divide it into 3 parts, or so we need 4 points. So that's why we are dividing our line into 4 parts. Okay, and here. Okay, after that, I'm going to, for example, between points 1. Okay, between points 1 are going to be points 1, and between points 3 or 2 is going to be points 3. You know, this divide curve, as you see, it will return a list. That's why I'm using list indexing syntax in here. We want some vector because we want to move it based on the vector. So, okay, we want a mid vector or middle vector, midvec, and we want to RG because RG or Rhino geometry, we can go here as I told you. Let me bring it. Okay, Rhino geometry, where is it? Okay, Rhino comment. Let me share my screen so you can see what I'm doing here. Okay, Firefox. Share screen. Okay, can you see my browser screen?
Yes, yes.
Okay. Okay, so we want, for example, we want to have a vector 3D. So we go to this address. Let me send it to you. It is Rhino comment documentation. Where is the chat box? Okay, here. Okay. You can go here and you can find Rhino geometry here or here. As you see here, we have Rhino geometry, and you can scroll down or search in the search box, or you can scroll down here, and you will see lots of things, or you can just press Ctrl+F, and the search box will appear here. We want vector 3D. Vector 3D is a class inside Rhino geometry library. So we can use it to create a vector 3D out of points. As you can see, vector 3D accepts point 3D. So let's go to Rhino. Okay, can you see the Rhino? Rhino, is it okay?
Yes, we can see the line. Yeah.
Okay, thank you. So we want to create a vector 3D. Let me rg dot vector 3D out of point 3D. So as you can see, you can just read the documentation here, and it will guide you through this. and it will say, yeah, you can just have point 3D, those things. And you can see that the documentation of Rhino geometry is really helpful. It will tell you all the details, and you're good to go. Okay, we want points. For example, point 2. We have points here. We have 4 points, and we want the third point, or as we can see here, because the indexing in Rhino starts from 0. So the point 2 dot x, it will just return the x value or x coordinate of point 2, as we have the list of points here. So we have this as the x of that point as our x coordinate of the vector 3D. Okay, and let's just subdivide. No, let's just subtract it by point 1 dot x. So it will, the x's are going to be in the middle of the point 2 and point 1, and comma points 2 dot y minus points 1. Okay, yeah, points 1 dot y, and comma points 2 dot z minus points 1 dot z. So as you can see, when, for example, let me draw something for you again. As you can see, a point here and a point here has x, y, and z. And this point has x, y, and z. So when we want to be in the middle of between these 2 points, we want a middle point here, a middle vector, as you can see. We want to just subtract the value of this point from that point. So every bit of the data is going to be subtracted from each other. That's why we wrote this. We wrote this part of the code. Okay, and mid vec is going to be rotated. Rotate is going to, it is inside that documentation. You can just go to Rhino common documentation and search for rotate inside vector 3D structure and class. So it will just give you enough information. So I'm going to just rotate it, and math.radians, okay, because Grasshopper by default use radians. It doesn't use degrees. So we are going to convert the degrees into radians so it can read the data very well. Okay, angle. We had angle here. Okay, we had angle here. So, and after that, we want to specify rg dot such thing, for example, no, rg dot. Okay, rg dot vector 3D dot z axis. So it will be the axis that it will be rotated around, that our mid vector is going to be rotated around the z axis of our coordinate system. So after that, I'm going to mid vec is equal to, let's say, rs dot vector unitize. Let's unitize it because we want to control the vector unitize. Okay, unitize it, and mid vec. Okay, because we want to unitize the value of our mid vec. So after that, we can multiply the value. We know that everything multiplied by 1 is equal to the initial value. So that's why we are unitizing our vector here. And mid-vec multiplied equal by length, for example. Yeah. And let's just provide another factor, name it as length, and set it as floating point. Okay, 12 points, let's say between 30, 0 to 30, okay, and floating point. Okay. And after that, let's say, for example, what we want a midpoint. Mid vector is going to be the vector for the movement of the midpoint. So that's why we created a mid vec. And midpoint here is going to be pt1 plus pt2 divided by 2 and plus mid-vec. Now here we involve mid-vec, and as you see, okay. And now we can return okay. Now we can return the value of the midpoint and the point. So we want the first point, the point 1, as we specified, and after that, between points, 1 and between midpoint and midpoint, we want, and between point 2, between points 2, yeah, and we want point pt2. Okay, so let's just call it, and we want, okay, and let's just call it okay, index out of range, line 13. Let me move the zoom here, and let me see what's wrong here, and I can fix it. Yeah, I think this is it. Okay. Or let's say okay. Let me try it. Yeah. Okay. Let me just. Yeah, it is working now. So, and we have just the midpoint. We have just the point, but we want to create fractals, as you can see. So we want to use it in a recursion. So what is a recursion? For example, let me a plus fractal. What was it? pt1, pt1, pt2, angle here. Okay, and
Mohammed, your screen is frozen. We can't see anything you're typing.
Okay, let me stop sharing and do it again. Yeah. Maybe there is something wrong here. Okay. Okay.
Yes, now we can see. Yeah.
Okay, thank you. Okay, so I think it is okay now. Let me fractal. Let me. I have a typo here. Okay, let me just change it to fractal. Okay, yeah, the fractal is not specified, so because I have a typo here, and let's just go here, and this is it. Okay. Okay, as you can see, we have the points now, and we can just change it like this and this, and they will be updated. So let's just connect them and make them a real fractal. They are just points. And let me go over it, and maybe we can have, for example, let's just call it, let me just do it from the beginning. Import Rhino script syntax as RS. So let's just call it create points, because we want to, please check line number 1. Yeah. Rhino dot Rhino Rhino dot, okay. Okay. Okay, so, and we want to import mass again, mass library, and we want to define something, create points. It was not necessary for me, but I have deleted it, so I am going to just do it again. PT1, PT2, angle. Okay, so, or maybe not the angle, just the 0.1, 0.2. So line, rs dot add line, PT1, PT2, and we have points, rs dot divide curve line 4. Okay. So we created our line, and let's, yeah, it is okay. And between points 1 is going to be such thing, and between points 2, okay, and points 1 and points 2. Okay, and we want a mid vector. Okay, and we want a mid vector rg dot vector 3D. Vector 3D, and 0.2 dot x minus 0.1 dot x and 0.2 dot y minus 0.1 dot y and points. Points here, points here, points here, points 2 dot z minus points 1 dot z. Okay. So and we want mid vector to be rotated like this, and we want mass dot radians angle and rg dot z rg dot vector 3d dot z axis, okay, around the z axis, and here Okay. There are lots of parentheses here. Okay. Midvec. One more time. Midvec is rs dot vector unitize. Here it is. Where is it? Okay, vector unitize and midvec. And one more time, lengths. We had lengths. Midvec is going to be equal lengths. Okay. So we have where does it go? Let me see where does it go? Okay, here. It was minimized. And here. Okay. So we want midpoint, and it is going to be taking a lot of time. 0.1 plus 0.2 minus this. And this here plus midvec. Okay. So we have midvec, we have those points, and let's return the values. Return 0.1 first. First we want 0.1 and between points 1, and we want midpoint, and we want between points 2, and after that we want 0.2. Okay. So this is just our points, you know. This is nothing, just our points. So we are going to create a definition for the snowflake. So we want another definition, snowflake, as you see here. We want first point, for example, or PT1, and we want PT2, and we want iteration, because it is a recursion. It is a recursive function. We want how many times it will iterate polyline. Okay. So we have a polyline and iteration and the points. And so if iteration was a positive number, so then go to and create some temporary points and create points, as you can see, and just PT1, PT2, just create some points for the temporary points. And this is this function that we wrote earlier. Let me just put more space between them. Okay. And we want a polyline. Let's call it poly, and rs.add polyline, and we want to have 10 points, 10.0, the first 10 points, and we want temp points, 10.1, and after that we want temp points 2 and temp points 3 and temp points 4. Okay. You know, that's what a polyline at Polyline accepts just a list of points. So we want to have temporary point 0, temporary point 1, temporary points 2. Those are just some temporary points that it is going to be created through this, you know, and we just use the list indexing to get and to have each index and each item of it. So here we want to do this. Yes, that's it. Okay. And we want to have if iteration equals 0, what happened when it is, sorry, if it is equal 1, not 0. I mean the first iteration, what should it be like? What should it be like? Okay, polylist list is going to be something like that. Polylist dot append poly. So dot append here, yeah, and polylist is going to be an argument here, not something that we have. It is like initializing your list, but in your arguments. It is a better way to have. Let me. Okay, no, it was it. Okay. Yeah, it is a better way to initialize your list, as I told you. So we want here, and now Snowflake lake here. We want a snowflake, for example, temp point, lots of typings, 10.0, temp points, 10 points, 1, and iteration -1. So it will just, every time it iterates, it will just subtract 1 from it. So we want to have polylist, sorry, polylist. Okay, as you can see here, we have a definition that is called a snowflake, and it is the main body of the function is this until this point. But we are calling that definition inside itself. So it is called recursive or recursion. As you can see, it will do a recursion, and it will do it all over until it reaches 1, until it reaches 0. So there is something funny if you search the web, if you Google it, for example, recursion, Google will ask you every time, did you mean recursion? Did you mean recursion? So it is something like that. And yeah, they made lots of jokes about it, and it is very helpful. You can just use recursion in your code. So let's go on and see what it will give us. Okay, so we want 4 of them, and now just go here and 1, 2, and 2, 3, 3, 4, 4. Okay, and after all, return poly list. Okay, I think there is something wrong here. Okay, so I think it is okay, and we created it, and now we just have to just use it, you know, a plus snowflake, yeah, pt1, pt2, what iteration, okay, iteration, and b. As you can see, we created our list, and let me just have iteration here. Okay. And not this iteration. And let's just have it as an integer number. Okay, this is our, okay, we need a number here, for example, 3. And let's call it a number and 13 mid vector. There is something wrong. Okay, yeah. Okay, so local value midvec reference before assignment line 14. Okay, I will just midvec. Yes, this is it. And global name angle is not defined line 14. Okay, let me just check it. And where is it? Okay. Okay. Oh, I have deleted the angle parameter. I had that, but I had deleted it. Okay. Let's just have it as float 0 between 19 and those kinds of things. Okay. So global length is not defined. Where is it? Okay. We have another and length. So let's set it as floating number because we want to have full control over it. 12, for example, maybe, or 3, not too much. Okay. So, okay. Let's have it. Okay, as you can see, we are here and we can just have it like this and it will be like that. And let's just have 3 of them maybe. So we can just create lots of, as you can see, lots of functions. Let me have negative. Okay. So let me just be back here and let's have, for example, here first and here. Okay. And you can see that we are having a fractal between 2 points, as you can see. Let me just move it a little bit and move this a little bit and change the iterations, and you can just do this and you can change the values, as you can see. And let me just have 3 of them. We can have a triangle that is made of snowflakes, for example, here, and let's say here, and let's say here. Okay, clear values and set 1 point. Yeah, and it will be like this and this. As you can see, we have such thing here. So I can do this, and this, and this. Oh no, not that. This. Okay, just this one, and this one, and this one. So every bit of it is going to be updated simultaneously and the same values. So as you can see, they are going to change like this, and the values are going to be like this. Okay, let's go to have some parametric volt. Let me move them, and after that hide them so they are not going to be on my way. Okay, we are going to have a lancet volt, a lancet parametric volt. It is going to be really, it takes a lot of time, but the result is something satisfying. Okay, so a lancet volt is a mixture of 4 volts that are interconnected together, and we can have it like this. So gh lib Python lib dot component as gh comp. I'm going to speed up a little bit because we are short on time now. Yeah, we are now 2 hours that sitting here, and Rhino dot geometry as RG and import mass. So, okay, let me make it bigger so we have more space to work on. And we want to create a function. So volt, we want to name it volt or dom or whatever. And we want 4 points, 0.1, 0.2, 0.3, 0.4. And we want a height parameter, and we want size height. And I'm going to tell you what is size height. We need a colon here. Okay, and size height, and we are good to go. And let's just create that function. We want just lots of point here. 0.1 is going to be such things. PT1 is going to be rs dot coerce 3D point. What is coerce 3D point? It will come. It will just you know, if you have a point, it will just return. It will just return the value of it and the UID or the ID of it. So because we are going to use Rhino geometry. Rhino geometry is using most of the time the ID of the geometries, not the geometry itself. So we need to coerce our geometries, points, lines, curves, everything. And let's coerce our 3D point, our first 3D point, that is point 3D and PT1, and copy this and paste it here and do it for all of them. 3D 2, 4, 2, 3, 4. Okay. And after that, we want to have X, Y, and Z coordinates of them, you know. So X equals to PT1 dot X and plus PT2 dot X and PT and we go on plus PT1. Let me just put some space between them so you don't get confused. And PT2, PT3X, PT4 dot X, and divide them by 4 because we want the average value of all of them. So, and PT1, PT2, PT3, okay, the X values, the Y, the Z. Okay, we want Z, we want Y, and let's have Y, a small, and Y, and let's just, okay, it is more organized. Oh, no, not this. Okay. And after that, I want a center point of the vault, because every vault, as this is, it is the center point here. Or let me show you here. The center point is going to be here. Okay. A center point, let me just say rs dot add point, okay. And I'm going to have the center point is going to be the top point on the top of the surface, you know, and the surface point is going to be x, y, z. That's why we need the values of it. So, you know, consider it as if you are looking it from the top view, you see something like this, you know, this is 0.1, 0.2, 0.3, 0.4. Let me draw it a little bit better. Okay, here, 0.1, 0.2, 0.3, 0.4. And if and what we have done here, as you can see, we are averaging the value of x and y and z of every and each point. So by this piece of script, we are making sure that the center point is always in the middle of them, and we are checking it and double checking it. So that's it. And the center point is going to be like this, center point, and you know, such thing. Center point going to be, we are going to coerce it one more time, coerce 3D point, because we want to have it, as I told you, center point, okay, center point. And we want to have some center, as I called it, center vintage point. You are going to see what it is. Center vintage point, rs dot add point here, point, let's don't, rs dot add point, and we want the center, let's just do it, it is quicker, that x, and this dot y, the y of it, and the z coordinate of the center point, z coordinate of the center point, and plus height. Let me just have height here. No, height. Okay, set it as a floating point number, and let me move it a little bit. Okay, we want to have 4 points here and here and here and here. So let me just have pt here, and we are going to have, okay, there are 0.1, pt1, pt2, set them as 0.3D, don't forget that, 0.3, 0.3D, 0.4, where is it, 0.4, 4, 4, 4, 4.3D, and let's assign the points to the containers. Okay, set 1 point here, and where is my cursor, and set another point, set this point, set that point. Okay, all of the points are set. Okay, okay. Okay, let's get back to the scripting part, and let me just, for example, 20. Give it this. Was it float? Yeah. Okay. We want some center vintage point, and you can just say that it is like that, and center vintage point, and we coerced it. We didn't coerce it, yeah? No. rs dot coerce 3D point center vintage point again. Let's go on, and we want midpoint 1 and x of it, and we want, let me copy this and the, no, not here, z. Okay, let's see what it is. We want point 1 dot x plus point 2 dot x, and we want them to be averaged, the average of them. Okay, let me just go here and do this. No, not here. And z here, we want the z value and we want the y value. And as you can see, we want the y value of it, and we want the x, y, and z of each of them, of each of those 4 points. So I'm going to copy this whole part and paste them here and paste them here. Okay, so it is like this: 4, 4, 4, 3, 3, 3, 2, 2, 2. Okay. We have, oh, PT1, PT1, PT1. Okay. PT2, PT3. Okay. PT3, 3, 3, and we have PT3, PT4. PT2, PT3, PT2, PT3, PT4. Every of them, and 4 and 4 and 4 here. And now we are going to get back to the first point, 4, 4, 4. Okay. Let me just go on, and we have first side main point here, and we want to add some point, add point rs.addPoint by midpoint 1 x and midpoint 1 y, midpoint 1, midpoint, yeah, and midpoint 1 z. Okay, because the add point accepts x, y, and z, so we have x, y, and z here of each point. Now we have a typo here. Okay, point. Let me check if I don't. Okay, I don't have any typo here now. And we want to have and height now, and the center point, we want them to be involved. So as you can see, center vintage point dot z and plus side height. We have side height here. Where is it? Here. Okay. And let me have side height. I have not specified it. Side height. Okay, and let's set it as float, and let's just do this, and do this. Okay. For example, this, or maybe this. Okay. Okay, let's go back there. First side main point, and you are seeing that, we want to coerce these two. rs.coerce coerce 3D, and now it is okay. So let's just copy this part and go here and change second. Okay, And let's just go here and do this. Now we want to change it to 2, 2, and we are good to go. Yeah. And we want to just do this for all of the points, just copy them and change them. And after that, we are good to go. And yeah, let me just copy them and paste them. And as you can see, it's just a copy pasting here because they use the same logic and we know what we are doing. And that's it, this is it. And let me just give them some space so you don't get confused. And after that, we want some vector up. Let's call it vector up because we want to move the points up. And ghcomp dot, we want a unit z, so we use ghcomp unit ghcomp. Let me, did I import it? Yeah. Okay. Dot unit, no, unit, what was it? I think unit z, yeah, a unit with z, capital unit z, yeah, unit z, yeah, that's it. Yes, okay. Yeah, let's just go, and we want some center arc, and we want a list of them, and we want to create some center arcs. Center arc, certain arc 1, and we want to have a rg dot arc curve. It is called arc curve, as you can see here. And arc curve is going to have rg dot curve, sorry, rg dot arc, not curve, arc, and we are having point 1 and point 1 and vector up, that vector that we made earlier, and center vintage center vintage point point. Yeah, so I don't have any typo. Yeah, that's okay, and that's it. And we want to just copy this part into this, into this, into this. Okay, and we want to append it to our list. Arc dot append. So append every arc we created. Let me just go here and let's just, okay, no, okay, and let's just do this, not that part, but the whole part. Okay, no, okay. So we want to have it for arc list 1 to arc center arc 1, center arc 2, 3, and 4. And 4 here is not 4. Okay. 4 here, no, 3 here, 2 here, and point 2, point 3, point 4, and line. Yeah, thank you. Vector. Yes. Thank you. Okay. So after that, now we are going to move to have they are the center, the middle arcs, and we want to have side arcs, side arc list here, and we want to have side arc 1. Okay, let me just side arc 1 rg.add curve, again add arc curve, not curve, arc curve, and let's just go to rg.arc, use rg.arc, and again we want four arcs, you know, and we want here 4 arcs, as you can see that we are going to have rg.arc1, and we are going to start at point 1, and after that vector up, not again vector up. First side main, where what was the, yes, here, first second side point. Okay, we are going to use this, and we are going to, of course, add it to dot append this to that. Okay, and let me just let me just copy this part and have it here. Okay, we want 8 of them, not just 4. Let me just rename them so we don't get lost. 3, 4, side arc 4, side arc 3, side arc 2, point 2, point 1. So, you know, it is going to be something like this, because we are going to have these curves, and as you can see, these curves and those others that are around here and here, and we want 8. Let me draw it in another. We want 8 arc curve, as you can see, 1, 2, 3, 4, 5, 6, and 2 back here. Okay, let me just clear it. That's why we are going to have 8 side arcs. So I think it is going to be 4, because 4 and 1 are going to be neighbors. Force. Okay, let's check if I don't have any. Yeah, and after that I'm going to have these. Let me just, okay, so point 1 force point, now we want point 2 and first, point 2 and first, yeah, and point 2 and second, point 2 and second, side main point, and we want to have let's call it 5, 5, 5, 6, 6. Let me point to first, point to second, point 3 second, point 3 third, point 4 third, fourth. Okay, point 4, and rename them as this, 8 and 7, 7. Okay, let me just check them if I don't have any problem, because I don't want to overwrite my arcs. Point 1, point 2, point 3, point 4. Okay, fourth side, third side, second, first, fourth, first, second, third. I think it is okay. We can move on to the next part of it. So we have lots of them. So, and I'm going to call it struct, for example, the whole main structure of the Lancel vault. And str1 is going to be rs dot, no, or str1 rs dot. Add loft surface. Why it is not working? Okay. Add loft surface, and I'm going to tell it that center arc and center arc 1 and side arc 1, I think. Yeah, the name is side arc 1. Okay, not this. Okay, and I'm going to coerce it. So because we want to coerce geometry, because it is a surface, we want to use coerce geometry, and this and that. Okay, and we want to add it that append a structure and append this str1 structure 1, or first part of the structure, to our list of structure, our whole list of structure. So we are going to do this 8 more times, not 7 more times, sorry, and just copy paste this to, not this, center arc 2 and side arc 1, and everything is going to be like this, as you can see. Center arc 2, and center arc, no, so we have 4 center arcs and 8 side arcs, so it should be center arc 1, side arc 2. It is going to be like this and this and this. Okay, here, and str3 and center arc 2 and side arc 3. So there are lots of repetitive tasks, but I'm going to tell you something that Grasshopper is not capable of doing that. So just let's keep renaming them, and I will tell you at the end of the session, this part, not the session, because sometimes Grasshopper is very limiting. So like this, that we are doing lots of repetitive tasks, but we don't want these repetitive tasks, as you can see. And side arc 4, side arc, center arc 2, side arc 4. As you can see, every 2 side arc is connected to the same center arc. So we have 1 here, 1 here, but 1, 2. We have 2 here, 3, 4. As you can see, there is a pattern. So copy this and copy that. Okay, paste it, and just center arc 4, 5, 3, it is going to be 3 and 5. 5 here, 5, and no, not this. 6, center arc 3, center arc 5, 6. No, that's 6. Okay, 6 and 6 here. Sometimes Grasshopper is that limiting that it even limits the Python. So it's better to use Visual Studio Code and hops. That's why I suggest you use you should use hops and Visual Studio Code. You have code completion feature, you have code suggestion, and those kinds of things. But in that way, you are not limited to the power and the computational power sources, power resources of Grasshopper. And now, let me just the last part of it. Okay, I think we are now good to 4, 8. Okay, so and it is going to now we want to return our structure. So we did this structure because we want the whole piece of it. So for example, now we want to have what was the name of the function? I cannot remember. So 130 lines of code to create a parametric dome, vault, whatever you want to call it. PT1, PT2, PT3, PT4. What was other arguments? So where is my okay? Height and size height. Okay, height and no. Height and size height. Okay, so let's see. Unit Z module has no attribute. Unit Z. Let me just fix it and let's see what's happening here. It was so frustrating. Okay, let me line 51. Okay, let's see. And okay, it is fixed. I don't know why it told us that it was something. Okay, so so this is our Lancet vault that is created. So I'm going to make it a little bit better, look better. Here, let me move the zoom controller. You know, we have our vault here now, and we can just move it or play with its values or such things. But I hope that you know, Grasshopper was had something like you know, something like a recursive function in here, but Grasshopper was not able to do this. Let me just show you what I mean in another Grasshopper file. Let me just hide it. Okay, and you know, this is what I mean. That part, that repetitive part, you know, that's what I mean. The last part let me just show you this part, that we had lots of repetitive tasks for the structure part. As you can see, around for 20 or 30 lines of code, it can be written like this. You can see that an index I, and for a range of in the range of that number of lengths of that center, that list of the arc. So we can just iterate over it. As you can see, we have it is changed as the number of it reaches an even number, not an odd number. So we could write something like this to get rid of this part, but Grasshopper is really limiting. So you have to, or you should use Visual Studio Code. It's better, you know. Last time we had there is something that I want to teach you, I want to show you, but I want to go to where is it, Visual Studio Code, because last session most of our participants, let me share it. Okay, can you see my Visual Studio Code screen now?
Yes, yes.
Okay, thank you. Because last time most of you texted me that you didn't get what I meant and how to use hops, and you said that you got confused. It was a little bit complicated, such things, you know. Hops is not that complicated, and you should know that it is the future of Rhino, I think, because you can do cloud computing things with hops, even local computing, cloud computing, everything. You can join into a server and read your data from that server and just tweak the data. So it is very capable. It is a game changer. And you can see, so we are here. And as I told you, where is my Rhino? Okay. As I told you, just type package manager, and you must install Rhino 7.4 or above to use hops, and search here hops, and hops will show up. Hops. Okay. It will go and fetch it. Yeah, as you can see, there is a newer version of hops. I can upgrade to that, but I'm not going to do this now. After this session, I'm going to do that. And it is a work in progress. McNeil and the developers of McNeil are working really hard on hops to make it better. It offer parallel computing, such things, and it is very powerful. But the syntax is a real bit different, you know, because it is like a thing between C# and Python, but it is mostly a Pythonic thing, as you can see. But when you want to specify a list in Python, where is it? When you want to specify a list in Python, for example, my list, you just use this syntax: my list equal to a square bracket, and the list is initialized. But in C#, it is a little bit more different than what you are seeing, that what we are using and seeing here. It is like, for example, we use something like, for example, let me show you. Let me make it bigger. Okay. Okay, let me get it bigger. Okay. This is a Python list. This is hops list. No, let's undo this. This is hops list, and where was it? Okay. In C#, we have such things. For example, let me just, for example, some numbers, you know, such things. For example, this. As you can see, we don't specify the data type of the list or the items inside the list in Python. We just give it a name and 2 square brackets, and that's it. But in C#, we should tell the interpreter or the compiler that it is a list. As you can see here, it is a list, and define the data type. It is an integer. It is it contains point3D. It contains surfaces. It contains dictionary, everything, and give it a name. After that, you should just initialize it by making it equal to a new instance of list class in C#. It is list class, and again tell it and say that it contains integers and something like this. As you can see, there is something similar here. We create a list, as you can see, list, and after that, but something similar and something in common between Python and C#. We don't use triangular brackets, but we use square brackets, as we do use them in Python lists. But like in C#, we specify the data type here. For example, we specify the data type, and we tell the interpreter that we want this list. It just include point and point3Ds, nothing else. But you, in Python, you can, for example, my list is going to be such things: 1A, 1.2 through everything. So it can contain any kind of data type, but as you can see, we need to specify it very strictly, and we cannot and the list cannot contain anything other than point3D, other than what you have told it. So let's go to where is Visual Studio? Yeah, let's go to Visual Studio, and here, first of all, if you want to use hops, you should install Flask and GH Server and Rhino inside. So first do this, and I have just told you, and I have written it in my GitHub repository, so in the README file. So everything is there, and you have just to copy paste it in the command prompt here. Yeah. Can you see command prompt now?
Yes, we could see
Okay.
it. Now it's fine.
Yeah.
Yeah, we can see.
Okay. So you come here and, for example, pip install Flask, and that's it. And if you want to know what to do, let's see, where is it? Okay. For example, you don't know what is the exact thing you have to tell the command prompt to install such thing for you. For example, pip install Flask PyPy. There is a website that is called pypy.org. As you can see, for the Flask package and library, this is it. But most of the time, this is like it. But sometimes it is not like that. So it's better to come to this website and see what is underneath and how you can install every package. So just copy this, go to command prompt, paste it, and hit enter. I am not going to hit enter now. It is installed on my PC. So, and first of all, as we saw earlier, we import our libraries, those libraries we wanted to use. And you can see, I'm going to import Flask, and from Flask, import. Okay. From Flask, as you can see, it will suggest everything. So you are doing your coding and your programming very faster in Visual Studio Code. It is better and everything is fine. So from Flask, import, yeah, Flask. And after that, I'm going to import GH server and other things that we want. GH hop server. Okay. Import GH hops server as HS. It is a shorter name for it. So HS is a shorter name. Import math, import Rhino inside, Rhino inside, okay. And Rhino inside that load. Let's just import before that, import system, import Rhino if you want to use Rhino geometry library. And after that, you have to load Rhino inside. Rhino dot inside. No. Rhino inside dot load. So it is okay. And this is the first part. And after that, hops is like a middleware. It is not a software or such thing. It is a middleware. It is it will just connect your Visual Studio Code and your Grasshopper with them and sync them together. So hops, this is the name of the variable or the instance. HS, as we know, no, HS dot hops. This is it, HS dot hops. We are using the hops function, the hops method of GH hops server library. And after that, I'm going to give it a name, app. As I told, this app here, app there, it's better to have the same naming for this part and your file name, app.py. Yeah. And we are going to Rhino inside. We are going to tell it that you have to use Rhino inside library to connect hops, as you can see, hops and Rhino software together. That's for it. That's for the middleware. So after that, just forget this part. And the main coding part is here. We have such things in here, an @ hops dot component. It is a syntax. We are telling it that we want to have a custom components through hops in Rhino. So, and this @, if you don't know what it is a symbol for Python decorators. So that's it. And we are going through this. So we want to have, for example, give it a name. The first argument is a name, and before that, you have to have a slash and semicolon and comma for the next argument. As you can see, rule name and nickname. So rule, what is rule? Rule is this, like a URL, because hops and flasks flask is a middleware, it needs a URL. So, and after that, we are going to specify a name. For example, give it the same name as here. It is recommended to do that, but you can change the name. But maybe you are going to have some problems and have some issues. It's better to be consistent with the naming. So after that, you can have nickname, description, category, subcategory, and category. Let me go to Rhino. I think most of you know this. And okay, this is Rhino and this is Grasshopper. Let me move zoom controllers a little bit. And okay, you know, this is such thing. Let me just make it bigger. This is a category, and this is a subcategory, and this is components, as you can see. And this is the categories, subcategories in here, and the components. So that's it. That's like addressing and giving names and making things organized. So let me go to Visual Studio. Where is the controllers of Zoom? Oh, okay, here. It is really difficult. Okay, where am I? So I'm going to give it a description. For example, description. This is a custom component, for example, that makes waves out of points, such things. And you can have icon, as you can see here, icon in Grasshopper should be a vector that has the size of 24 pixels by 24 pixels. So you need to be careful about this. So the most important thing here is this and the name, and most importantly, the URL or whatever that it is called in hops. The rule, as you can see, the rule is wave, and I'm going to tell you what it is and how we are going to use it. So okay, and after that we have inputs and outputs. If you remember, let me go to Rhino one more time. Where is it? Okay. Where is okay. As you can see, we have inputs and outputs, and we want to just specify the access and tell it what access it must use, and the data type and everything, and the names, everything, you know. But as you can see, we don't have such GH Python components back there in Visual Studio Code. Let's go to Visual Studio Code. And we want to specify the inputs and outputs like that, but in a better and much neater way. Okay, inputs here, we have a list of inputs. And like this, for example, we want to hs.hops, for example, hops integer, because we want x and y, and we want to use for loops. So for loops accepts, and the range function accepts only integers. So you see, we specify the data type of our input back here now. Not we don't go to another menu or such things. We just specify it now. So hs hops integer, we give it name, for example, X, we give it a nickname, or you can just type nickname, or you just go it one by one, go through it one by one. Okay. X, and after that we want to have a description, for example, X input, such things. You can just, or you can just you can specify the access parameter, as you can see, as we have in GH Python component in Grasshopper. As you remember, we had it list as access, item access, and tree access. So you can see, for example, HS hops parameter, where is it? Hops parameter access dot, for example, list, but we don't want list. We want item. So the default value, as you can see, it is the default value, item. So I don't want to specify it, so I go with the item. And X input and Y input, just let me. And I want a Y because I want to have a grid for the wave. Okay. And we want hops, hs.hops number. Okay. So I want to give it a name. We want to have, for example, height, and a nickname, h, and a description, height of the waves. hs.hops number. Number is the equivalent of float in Python. You see, integer is integer, number is floating number. Okay. And we want amplitude of the wave. So A, for example, and the description is amplitude of the wave. Okay. So we want to specify the outputs now, and here, okay, we want to have a surface, just a surface, nothing else. You can have multiple outputs, but now in this case, we just want a single surface. So hs.surface, hs.hops, where is it? That hops surface. As you can see, we are going to give it a name, for example, surface S, and a description, for example, a surface made up of wave, a list of points, such things. A surface that is made up of a list of points yeah, and we are good to go. We specify our name of the function, the URL, the description, and the inputs and the outputs. So now they are just the inputs, they are just the cover, the skin of it. So they are just the inputs and the outputs at the inner, and now we want the engine and the backend of the component. So we write a definition, we call it wave, because here and here we have wave, and we want to be consistent, so in case we don't want to have any problems. So X and Y, because we have 4 inputs here, as you can see, we want to give it 4 inputs to our function. X, Y, and height and amplitude, Okay, and semicolon after that. We are going to say that points. This is where it is a little bit different with pure Python, because I told you Hops is using PythonNet. PythonNet is another version of Python that is similar to some aspects of it is similar to C# and .NET C#. That's why they call it PythonNet. .NET, Python, PythonNet. And points, we are going to create points like this. That's why we import system. System is something for using the Windows packages or such things, using .NET packages. So that's why system generic, as you can see. System collections okay, if I'm not mistaken, yeah, collections and generic that, and after that we want to have list. That's how we define a list in PythonNet. And we want to specify the data type that the list accepts. So now we want to try to give it such thing that it accepts. Rhino.geometry, geometry with capitalized G, geometry. Okay, geometry and that point 3D. Okay, after that, this is it. So this is just the syntax. It is not something very complicated or such things. Just see this as this, you know, see it as points, this, nothing else. And you just specify, you just specify the data value of it, but by Rhino geometry point 3D. Just that, you just specify the data type of your list. So let's go and create a for loop for I in range X and for J in range Y. Where is it? Okay, Y. Now, as you can see, so we have a grid. We have a 2D grid. Okay, we want to have point dot Rhino dot geometry point. Every point is going to be like that, point 3D. Where does it come? Where does it this thing or that thing come? Let me go to Firefox. Okay, let me go to my browser here. Okay. As you can see, Rhino geometry and point 3D, point 3D. Point 3D method. As you can see, the point 3D. The point 3D is a subclass, is a class inside Rhino, the Rhino environment, and the Rhino geometry library. So we use it like that. If we want to just point to it, if we want to use it, we use it like that. Point. No. Where is the drawer? Okay. Where is the? Let me annotate it one more time. Okay. We want to use it like this. Point 3D. That's it. That's why. Where is it? That's why we use it in here. As you can see, Rhino.geometry.point3D. So we specify that the point is a point 3D, and we want to use the constructor of that class. Every class has a constructor. So that's it. Let's where is it? Okay. And point 3D, and now we have point 3D here accepts just floating points. So float, I use float function. It is a built-in Python function that makes every integer and every kind of number into a floating point number. It is for the sanity check. That's it. Float I, float j, and mass dot sign I multiplied by height. You see height here, and the input is coming from here. So it is they are the argument that the values are coming from the inputs. So mass dot sign, okay, and for example j plus height, sorry, multiplied by height and multiplied by amplitude. Okay, so we want to points dot add. Why we don't use append here? Because as I told you, it is important to know you have to just read about PythonNet and the syntax of PythonNet, and don't be afraid. It is not very complicated. It is just, instead of append, you just use add. It is even shorter. So that's it. Yeah. And points dot append, and we want the surface. As you can see, our output is a surface. So we want surface, no, surface. Okay, and we want Rhino dot geometry dot NURBS surface. And if I don't want to just I want to just check it if I'm spelling it correct. So I'm going here and search for NURBS surface, and let's go back and let's go to Rhino geometry. Surface. Let's see just this surface class, and let's see where it is, and nerves. Okay. Rhino.geometry.nerve surface. Inside the surface, just let's go on. We are 1 more hour. And let's go back to here. Yeah. Nerve surface that create from points. That's the method inside that class. So create from points, and we had points here. We had a list of points, and we want to just x, y, z. That's it. It is the argument. So and we want to return it. Return surface, and we created it. So now we should tell Python and its interpreter that whenever we call this function, the wave function, and this name, we want it to run this piece of code, to run this piece of script. So in order to do this, we have such things. If name, it is just a piece of syntax. You don't have to even get what it is. So I don't want to make it more complicated. So if name equal to main, there are a special kind of built-in functions inside main. Is a very special kind of built-in functions in Python. So if you want to know hops.server, and we want to start, yeah, debug true. Okay, so, and you have to save it, and press Ctrl S and save it wherever you want, and you should go to the terminal inside Visual Studio Code and type Python space /app.py, the name of your file. It is the name of your file, and press enter. So let me, Python is not recognized. Oh yeah, let me just app.py. Okay, let me just df. Okay, I use my other kind of Python version because I have lots of Python versions on my system. Some of them have the packages, some of them not. Python.app.py. Let me change it back to the base of it. Okay. No, I cannot remember which in virtual environment I used before. So app.py line 13. Let me just check it one more time, and I will be here. Let me check the script, and let me just save it. Okay, Torch 19, no. Okay, so okay, so thank you, Gustavo. I'm glad to that you are here. Okay, so the server is started. So you know, most of the time it says that localhost 5,000 such things, but it is not correct. You know, and I have specified some other thing. You should use it. I will send you in the chat box this one, and use it in your Rhino. Let's head on to Rhino. Let me okay, and let's head on to Rhino. Do you see my Rhino screen now? Because it is lagging for me. I have some lagging problems. Hops,
yeah, we can
and
see.
bring hops. Okay, thank you. Bring hops, this component after you installed hops from package manager. So from here, after you install it, you have to restart your Rhino, and it will appear here under the parameters tab. So double click on it, and it will ask for the URL. As I told you, the URL was this. You see this one. But before this, you have to specify the path to the server. So a local server, not a server on the internet. You can use servers on the internet, but we are just using local servers. That's the main point of using hops, you know. And the other point is that we harness the power of parallel computing and such things, but those features that Grasshopper does not offer by itself. So we want to have this, just the wave, because it has the slash here, and press OK. And as you can see, it is an integer. As you can see, it is an integer, empty integer parameter. It tells us empty integer parameter. We know that it is an integer. An empty number parameter, and empty number parameter, amplitude of the waves. As you can see, whatever I wrote there uh, um, inside our scripts and inside here, for example, amplitude of the waves of the amplitude and hops number, it is a floating number, and the name of it is amplitude, and the nickname is A, the description is this. So we go here, and you can see everything is here. Amplitude, A inside parentheses, and the description, and the data type. So I'm going to just do this, for example, 12, 12, and 1.2, and this one. Okay, let's do it. And you see, let me just hide it. Okay, you see it appears very well and very beautifully. As you can see, we have lots of those smooth surfaces like a wave, and we can just play with it and tweak it. As you can see, that's as simple as that, and it is very powerful. As you can see here, we have it. Okay, that's it, and we are finished. Thank you, Gustavo. Anytime.
Yes.
If you
I
have
think
any question, it is a very long session, you know.
yeah, it's been almost like a
Yeah,
3 hour session. But I think this was a much needed session also. And while Hops is a very versatile platform, it's equally important to learn Python basics and also some of the things in basic Python components. But yes, I'll go to students in case anyone has any questions or comments and would like to ask Mohammed directly.
I wanted to teach all these things on my
Yeah,
first session. So
yeah.
uh,
No, it's quite extensive, and I think
yeah,
we've given everyone a lot to think about and work on as well. So
yeah,
yes, um, Andrea
sure.
says thanks. Yes, and
Thank you.
just to wind up on the session, this is also the last session for 2021, but it's only beginning for us to do many more tutorial sessions in 2022. We will see you all and we'll keep you all posted with our next session. So we will be doing the next session on 8th of Jan. We will continue with our Saturday programs. We'll continue even with more of Arabic and Farsi sessions, and we love to hear from the audience, from the students who have connected with us on Zoom, and we would love to also see your work outcomes. You can reach out to us on Instagram, on Discord, and yes, we look forward to meeting you all in 2022 now. Thank you.
Happy holidays, and thank you,
Yes,
Boblin,
happy
for
holidays.
being here. Thank you, Gustavo. Thank you, everyone. Happy holidays to you. Yeah, if you had any question, I'm on the Discord. You can ask me, and yes, or maybe you can just uh, open a thread or open an issue on our GitHub repository, and I can just address your issues and problems. So yeah, everything.
Yes, I think Caesar also is asking something. He is asking if you have any channels or page with more code samples.
More code samples. I can provide that on my GitHub, but I have not uploaded it to my GitHub repository. I will do it, and I will let you know, of course.
Yes,
I
the
have, yeah, I have
GitHub.
a Discord channel, a Discord personal channel, but not lots of members in it. Most of them are from my previous workshops. I can just, yeah, send you a link to that maybe now. We are not so many people there. Let me, yeah, invite people. Okay. And you can use a Discord channel of Digital Futures too. I'm always there, and I can answer it to all of you. And you can direct message me, everything. Feel free to ask everything.
Yes. Okay. Thank you all. See you all in the next.
Thank you, everyone.
Yes. Bye.
Sure.
Thank you, you all.
Thank you, Gustavo.